Hi everyone, welcome to this video. Today I will break down how I reduced infrastructure cost by 20% in a real-time banking system by optimizing server load. In many high-traffic applications, companies often over-provision servers to handle peak loads. This results in unnecessary expenses for idle resources during non peak hours. The goal was to optimize resource allocation, reduce redundant workload, and ensure fast, reliable performance without overpaying for infrastructure. Let's explore how I did it. The biggest challenges we faced were high CPU and memory usage. Our microservices consumed excessive resources due to redundant operations and insufficient computations. Inefficient database queries. Frequent full table scans and unindexed queries increase server strain, slowing responses. Unoptimized load distribution. Some servers were overloaded while others remained underutilized. Scaling cost. Automatic scaling was reactive, leading to cost spikes during peak traffic. To address these, we need a strategy that balanced performance, cost, and reliability. Strategies for server load reduction. Here's how I optimized our infrastructure and reduced cost. Autoscaling with predictive analysis. Instead of traditional autoscaling that reacts to spikes, we use predictive scaling with machine learning models to anticipate demand based on historical traffic. This pre-warmed instances before peak hours, ensuring optimal server usage without excess idle time. Example, during payday transactions, we pre-allocated instances just in time, avoiding unnecessary scale-ups. Redis caching to reduce database hits. Frequently requested data like account balances and transaction history was cached in Redis, reducing database queries by 40%. This cut down CPU utilization on database servers, allowing us to scale down database instances without affecting performance. Asynchronous processing for non-critical tasks. Instead of blocking API calls, Non urgent operations, example sending email receipts, logging transactions, were handled asynchronously using RabbitMQ. This freed up API servers to focus on critical requests. Efficient query optimization. Indexed high read tables, reduced expensive join operations, and optimized log queries using explain analyze in PostgreSQL. This significantly lowered database load and improved response times. Each of these strategies reduced server strain, improved response times, and cut infrastructure costs. Here's the final impact of these optimizations: 20% reduction in infrastructure costs by eliminating redundant workloads and optimizing resource allocation. 40% fewer database queries. Caching and query optimization significantly reduce strain on database servers. Balanced autoscaling. Predictive analysis ensured servers were available only when needed, reducing idle time. The key takeaways are: don't over provision servers. Use predictive scaling instead of reactive scaling. Reduce database load. Use caching and optimize queries for efficiency. Offload non critical work. Asynchronous processing prevents API bottlenecks. Monitor and automate continuously. Use real time monitoring to detect inefficiencies. By applying these principles, you can improve performance and cut costs without sacrificing user experience. If you found this helpful, like and subscribe for more insights on system optimization.